Mathematics in the Modern World, Propositions. What is propositions? A proposition is a declarative sentence, statement that is either a true or false, but not both. It is the basic building block of logic. The truth value of a proposition is true, denoted as T, if it is a true statement, and false, denoted as F, if it is a false statement. Examples. Number 1. 6 plus 4 equals 10. It is a true mathematical sentence, but it is not a declarative sentence. So we need to put it in words for it to be a declarative sentence, which is the sum of 6 and 4 is 10, which is a proposition. So we can say that example R is a proposition. Example number 2. Look at the clouds. It is not a declarative sentence. Therefore, we can say that example P is not a proposition. Now, let's look at these examples. Example number 1, Rodrigo Duterte is the President of the Philippines, which is a proposition because it is stating fact and it is a declarative sentence. Example number 2, what time is it? Example number 2 is not a declarative sentence, so it is not a proposition because it is not declaring anything. Example number 3, grass is green. It is stating fact because grass is really green, so we can say that example 3 is a proposition. Now let's determine the truth value of the proposition. Number 1, Seoul is the capital of South Korea, and it is a true proposition. Number 2, Taylor wrote the song Position. So if you have listened to the song Position, you will know that Taylor did not wrote the song, so it is a false proposition. Number 3, 2, 4, 6, 8, 10 is a set of natural numbers, and it is a true proposition because a natural number is an integer greater than 0. Now, let's determine if it is a proposition or not and give its truth value. Question number 1. Did you finish the task that Mr. Anderson gave us? And this is not a proposition because it is not a declarative sentence. Question number 2. You could have been killed if the cops didn't come early, and it is not a proposition because it's an exclamatory sentence, not a declarative sentence. Question number 3. I love ice cream and vanilla is my least favorite flavor, and it is a true proposition. Here are some symbolic forms in mathematics that we need to be familiarized with. Number 1. 2 is a natural number, and the n symbolizes the set of natural numbers. Number 2, negative 100 is an integer, and the z symbolizes the set of integers. Number 3, the constant pi is an irrational number, and the q symbolizes the set of natural numbers. Number 4, the constant pi is a real number, and R symbolizes the set of real numbers. In number 5, we can read it as the square root of 2 is less than 2. And the last, number 6, the set of all natural numbers is a subset of the set of all integers. The set of all integers is a subset of the set of all rational numbers, and the set of all rational numbers is a subset of the set of all real numbers. And now, we are going to talk about the simple and compound propositions. Compound proposition. A compound proposition is a simpler form of proposition that uses logical connectors like if, and, or, not, and then. It can break down into more primitive proposition. Simple proposition. A proposition is simple if it cannot be broken down into more propositions. So here are some examples of simple and compound proposition. Compound proposition. If it is sunny outside, then I'm going to walk to school, or I will drive if it's raining. The logical connectors are if, then, or. So when we put it in symbols, if S, then W, or D, if R. So if we connect it to the simple proposition, the S is the it is sunny outside, the W is the I'm going to walk to school, The D is the I will drive, and the R is the it is raining. Another example, the compound proposition is either I'll pay for the rides and you'll pay for the drinks, or if John shows up, he'll pay for the both. The logical connectors are if, then, or. So when we put it in symbols, M and D, or if, then, P and Q. And when we put it in simple proposition, the M is the I'll pay for the rides, the D is the you'll pay for the snack, the J is the John shows up, the P is the John pays for the ride, and the Q is the John pays for the snack. Another example, the compound proposition is I went to the mall yesterday and I bought a shoe for a few bucks. The logical connectors are and. When we put it in symbols, it is W and S. So the simple proposition is the W is that I went to the mall yesterday, and the S is I bought a shoe for a few bucks. So in this example, we have two simple proposition, which is the W and the S. Another example, the compound proposition is Joe made the cookies and Taylor decorated them. The logical connectors are and. When we put it in symbols, it is J and T. So in simple proposition, the J is the Joe made the cookies and the T is Taylor decorated it. And we have two simple proposition in the example above. Now let's see another example. The compound proposition is, if only Jake was not busy, then we could probably watch a movie or play ball in the backyard. The logical connectors are if, then, or. And when we put it in symbols, J, then, R, or B. So in the simple proposition, the J is Jake was not busy. The R is we could probably watch a movie. And the B is play ball in the backyard. So in this example, we have three simple propositions. And last example, the compound proposition is she said that she's fine but her look says no. And our logical connector here is but. And when we put it in symbol, it is S but N. In simple proposition, the S is she said that she's fine. The N is her look says no. So in this example, we have two simple propositions. That's all. Thank you for listening. I hope you learned something from me.